This is Algebra 2, a lesson on graphing absolute value functions. All right, is everybody looking? Everybody look at me. Every absolute value function has the absolute bars in it. When you see the absolute bars in a function, the graph is going to look like a V. It's going to look like a V. It is not going to be a line. It is not going to be a curve. It is going to be a V. It's going to be a wide V. It might be a narrow V. It might be an upside down V. It might be a real skinny V. It might be a wide V. But it's going to look like a V facing up or facing down. Absolute values look like a V. They are not lines. Okay, now we're going to figure out why. All right. This is called the parent function of an absolute value. Anytime, like the parent function of a line is y equals x. It's before anything is added to it or anything is multiplied. And the reason it's called the parent function is because it's not been transformed. When numbers are added or multiplied, it changes what the function looks like graphically. So we're going to look at the parent function. And we're going to look, okay, this is function notation. This says f of x, this is not f times x. This is f of x equals the absolute value of y. This entire term is equal to y. So when I did my x and my y's, I could say that this axis is x and this is f of x. So f of x is the equivalent to y. Now if I wrote f of 2, everybody listening? We're going to get to function notation later. This says when x is 2, what is y? That's what that's asking. When the value of x is 2, what is y? Got it? Does everybody understand that? All right. All right, so we're going to look. When x is negative 2, and I substitute negative 2 into that function for x, what is the y value? Positive 2, right? What does the absolute value mean? The absolute distance from 0. That is correct. Neither positive nor negative. It's the absolute distance from 0 on a number line. So the y value is 2. When x is negative 1, what's y? When x is 0, what's y? When x is 1, what's y? When x is 2, y is? Okay, so no matter what I put in to x, y is always positive in the parent function. There's nothing graphed below the x-axis. And it looks like a V. All right, now, let's think about what happens if I change the function from this to if I changed it to f of x equals the absolute value of x plus 1. Let's see what happens. Let's just substitute in negative 2, 0, and 2 into the function. Okay, when I substitute negative 2 here, what's the y value? No. 3. Everybody see that? negative 2, absolute value of negative 2 becomes 2. 2 plus 1 is 3. Got it? Okay. Now when I substitute 0 in here, what's the y value?
1.
0 plus 1, 1. When I substitute 2 here, it's 2 plus 1, 3. All right, now let's look. This is negative 2, 3, 0, 1, and 2, 3. This 1 is called a vertical shift up if it's positive. It's down if it's negative. It took this parent form and shifted it up 1 unit. So outside here shifts up 1 unit. That's your first and your second transformation on this sheet. Do you see it? Absolute value of x plus d, absolute value of x minus d. Those are shifts up or down by this many units. Does everybody see that? Now, all right, now this is going to be our function. This is the next transformation. And we'll do the same numbers, negative 2, 0, 2. All right, when I substitute negative 2 in for x, what's the y value? Negative 2 plus 2 is 0, so the y value is 0. Negative 2 plus 2 is 0, so the absolute value of 0 is 0. Got it?
Yeah.
If I substitute negative 2 in here.
Oh, okay.
Got it? Okay, now substitute 0 in here. The result is 2. All right, substitute 2 in here. 4. Okay, so now I have negative 2, 0. I have 0, negative, no, I have 0, 2. And then I have, wait, negative 2, 0. 0, 2. And then I have 2, 4. All right, I've got to go back, huh?
It's just a very big one.
Okay, yeah, I have to go back to negative 4. Let's do one more. Negative 4, what's the result here? When I put negative 4 here,
2.
positive 2. I needed my other side of the V. So that, let me see if I have another purple marker. I'm just going to go with this one. So that my V looks like this. It's not any wider. It's the same width. But what has happened from the black to the purple?
It has shifted
Left
left 2.
by 2 units. 1, 2. You always look at the vertex. You're looking at the vertex. So the form is x minus c. I believe that's what most books do. Okay. This c value here is a horizontal shift by the value of C. All right, so everybody look. Verticals are the same. If it's +1, it's up. If it's -1, it's down. Got it? Verticals are the same. Horizontals are the opposite because of this negative. In order to make that positive, it has to be minus -2. So this would really be written as x minus -2. -2 is my C value. But anytime it's inside the bars or inside parentheses with x, you think opposite. So +2 is to the left. -2 is going to be to the right. Got it? All right, so let's just look at several functions. I'm just going to write several functions, and you're just going to tell me vertical shift, horizontal shift. All right? What is that? It's what?
Vertical.
Vertical shift down by 4. Everybody got it? Vertical shift down by 4. So my vertex is going to be at -4, and it's going to go up that way. Got it? All right. That's x -3.
Right by.
This is what? A horizontal shift right by 3. Okay, what is this? Vertical shift up by 2, and this is horizontal shift left
By 5.
by 5. So I have the vertex here. It's opposite, same. That would be where my vertex is, the bottom of my V. So if I were graphing this, it would be at -5, 2 here, and it would go up. Do you see that? It gives me my vertex. Everybody see that? All right. What if I wrote all right, just everybody think of where the vertex is, the bottom of the V. Everybody think. Okay, this is vertical or horizontal? Vertical. Vertical shift down by 1. What is this, vertical or horizontal? Horizontal shift left by. All right, so where's my vertex? Opposite, same. Got it? All right. Now we need two more transformations. The slope of all of these has been 1. So on the V, on both sides, we've risen 1 as we ran 1, risen 1 as we ran 1. We're going to change the slope, and we're going to reflect it across the x-axis. So instead of opening up, it's going to open down. All right, so first we're going to change the slope. All right, somebody give me the vertex. I don't even know if you can see that on the video. This is 1/2 bars. X minus 2 plus 1. All right, where's my vertex? Opposite. Same. All right, so my vertex is going to be at 2, 1. Remember in the parent form, it was at 0, 0. Now, this becomes my slope. So we're going to rise 1 as we run 2. It's going to be a fatter V. Less than 1 makes it a wider V. Greater than 1 makes it a narrower V. All right, so we're going to rise 1 as we run 2. Rise 1 as we run 2. You see that? Rise 1, run 2. Rise 1, run 2. I go both sides up on from the vertex. So it's going to be a wider V. All right, now let's do f of x is 3. Let's move it to this side. X plus 1 and bring it down. All right, where's my vertex for this one?
-1, -2.
-1, opposite, same. -1, -2. There's my vertex. My slope, I'm going to rise 3 as I run 1. So from here, I'm going to rise 3. 1, 2, 3 as I run 1, and I'm going on both sides. I'm going to the left and to the right. 1, 2, 3, and run 1. So that this is a narrow V. Y'all see the difference between changing the slope when it's a fraction? It's going to be a wider one. When it's a number, it's going to be a narrower one. It's actually called a vertical stretch. When this number gets bigger, it's as though what happens is somebody takes the end of it and pulls it up and closer to the y-axis. It's actually called a vertical stretch. When we get to calculus, that's what we're going to call it, a vertical stretch. I mean pre-calculus. All right, so we can change the slope. We can move the vertex from 0, 0. And now, instead of opening up, we're going to do a vertical reflection. A vertical reflection reflects across the x-axis. So instead of opening up, it's now going to open down. All right, so let's do some negatives. This looks like okay. All right, somebody tell me where the vertex is. Have I moved it horizontally? Have I moved it horizontally? No. Nothing added or subtracted, so that coordinate stays 0. Then I've moved it up 3. All right, so we're at 0, 3. That's my vertex. That's going to be where my V goes from. Because it's negative on both sides, it's going to go down. So we're going to fall 1 as we run 3. So we're going to fall 1 as we run 3 on both sides. Fall 1 as we run 3. And I was expecting a wide V because it's a fraction. Make sense? So far? So far, so good?
Yes, ma'am. Yes.
Excellent. Okay, now let's do another one. Okay, now, where did I move the vertex to? Did I move the vertex up or down? Did I move it up or down? Up or down would be out here. There's nothing out here, so my y-coordinate is 0. I could put plus 0 there, but I don't have to. But what's my y-coordinate for my vertex? Positive 2. So 2, 0, right here. Now, I could write 2 over 1. I fall 2 as I run 1. So I'm going to fall 2 as I run 1 on both sides. And that looks like this. All right, so we have 4 transformations. We can move it, that vertex from 0, 0, we can move it up, down, left, or right. We can change the slope of the sides of the V. And we can reflect it across the x-axis. So putting all of them together, this is every transformation that I just taught in 20 minutes. Crazy. We're going to do this with every type of function next year. We're going to have all these transformations next year in pre-calculus to all the functions. We're going to do some of these with the quadratic function. We're going to do actually all of these with the quadratic function. It's lesson 100. So it's next semester. All right. So what is this to? It's a vertical shift up by 2. So it's a vertical shift up 2. What is that?
That's down.
No, it's horizontal.
It's right. Right.
To the right by 2. So it's a horizontal shift right by, not 2, 5. The number is 5. All right, what is this negative? It reflects across the x-axis. So instead of opening up, it opens down. It's called a reflection. It reflects, reflection across the x-axis. And what is the 5 halves?
Rise over.
Rise over run, it's slope. It changes it to be either narrow or wider. Is this going to be more narrow than the parent or wider? Is it greater than 1?
Yes.
It is. 5 halves is greater than 1. So it's going to be narrower. Greater than 1 is narrower. Less than 1 is wider. Okay? All right. And we could graph this, but let's look at the bottom of your page. This first page, number 8. Let's graph number 8. So they use y on this sheet. Where's my vertex for number 8? My vertex is at -4, 9. So here's my vertex. Does it open up or down? Up. And what's the slope? I rise 2 as I run 1. I rise 2 as I run 1. It's like a deer. Y'all, do y'all see a little deer? No. Little reindeer. Okay, use your imagination. All right. So do y'all get this? Yes? Are you getting it? No, you're not. You should be. Go to page 3. I'm going to have y'all graph some of these here before we leave. I want you to go to page 3. Could we then go from a graph to the equation? Okay, if this is the vertex, and this is the slope, and it's a negative if it opens down, then look at number 1 on page 3. What is the vertex for number 3?
-1, 2.
Does everybody see that? -1, 2. Okay, so this is opposite, same. Opposite, same. See how we got that? Has everybody got that? Okay, now, is it open up? So this is going to be positive. This is going to be positive. I'm expecting a positive. And then what is my slope? It rises 2 as it runs 1. That's great. It rises 2 as it runs. No, it rises 1 as it runs 2. It's 1/2. Thank you. It's y. It rises 1 as it runs 2. Thank you. All right. Look at number 2. Let's come up with the equation of number 2. Where did we start? We started by asking, where's the vertex?
-2, -1.
Does everybody agree? -2, -1, opposite, same. So it's opposite, same. Everybody got that? Opposite, same in the equation. Is it open up? It's open up. So this is going to be a positive number because it's open up. Okay, what is the rise over the run? Now it's 2. Is it 3?
3.
Oh yeah, it's 3. It rises 3 as it runs 1, so it's positive 3. Are y'all getting this? All right, let's look at number 3. Number 3, what is the vertex? 0, 4. So I'm not doing anything to x because I'm not going to add 0, but I'm going to add 4 on the outside. It opens down, so this number is going to be negative. We're on page 3. Right here, right here, right here. No. Yes, yes, yes. Okay. Number 3. What is the slope?
-3/4.
-3/4. Does anybody agree? We fall 3 as we run 4. -3/4. All right, what about number 4? What is it? Where's our vertex?
-2, 5.
So our vertex is -2, 5. That's opposite, same. So it's x plus 2 plus 5. Does it open up or down? Down. So this is going to be a negative slope. And what is that slope? It's, yeah, just a negative. You don't have to put 1. Just put a negative. All right, let's go to page 4. We're going to graph these. On page 4. And we're going to talk about them. All right, V is for vertex. So where's the vertex? -1, -3. All right, that's where my vertex is going to be. -1, -3. Okay, AX is axis of symmetry. All of the absolute value equations, as well as the quadratics, the second degree, they have an axis of symmetry. And the axis of symmetry goes through the x value of the vertex. So there's this axis of symmetry right here at x equals -1. And what that means is what I graph on the left-hand side is a mirror image of what's on the right-hand side. And that is also true with every second degree equation. We're going to have an axis of symmetry. All right, this opens up. And what's my slope? I'm going to, what am I going to do? Rise 2 as I run 1. All right, so this one opens up. On the test, I'm only going to ask you to graph an absolute, or I'm going to ask you what is the equation of this graphed absolute. So those are the only 2 types of questions I'll ask you. Graph or what's the equation. But I'm saying words to you because the first time I don't want pre-calculus to be the first time you hear these words, okay? All right, so listen. There's a min or a max. That just simply means the smallest value. This one has a min because it opens up. Right here, that's the min. So all curves have mins and maxes. This would be a min because it's the smallest value in that curve. This would be a max because that's the highest value in that curve. And in calculus, there's this slight connection to calculus. In calculus, the derivative is when we look at what is the slope of a line tangent to a curve at specific points. And at the max and the min, the slope of a line tangent to the curve is 0. So you know it's changing directions. From here it's increasing, it reaches a maximum point, and then it begins decreasing. All right, here, that's a min. That's the minimum value. Got it? D is for domain. Domain is all of the x values that a graph can be graphed. And for this, for any polynomial, and this is a polynomial, function rather, not a polynomial, function. For any function, the domain is all reals. So as I can graph negative 100, or I can graph a positive 100, or I can graph negative 1,000, or I can graph positive 1,000. Any x value I put in can be graphed. So it's all reals. Got it? All reals. The range has to do with the y values. Because there's a smallest y value, the range is not all reals for y. The smallest y value is negative 3. So the range would be y has to be greater than or equal to negative 3, because negative 3 is the smallest range. Make sense? Okay. Now let's look at number 13. And then we'll let you graph a couple. All right, number 13 is y equals negative 2, x plus 3 plus 4. All right, where's my vertex? My vertex is negative 3, 4. So where's my axis of symmetry? At the vertex. There's an axis of symmetry at x is negative 3. Always at the x coordinate. All right, because there's a negative, it opens down. So do I have a minimum or a maximum? I have a maximum. So I have a max at y, it's the y, at y equals 4.
Is the min max always 5?
Yes, we look at, or you could use the coordinate point, yes. All right, and what's my slope? I'm falling 2 as I run 1. I'm falling 2 as I run 1, falling 2 as I run 1. It opens down. Now what's my domain? What did I say about domain? Domain is what values? X or Y? X. Everybody, domain is X. And it's always all reals. But now what's my range? My range is the Y values. So what has to be my range? What's the highest value Y can be? 4. Can it be greater than 4? It has to be less than or equal to 4. Later on in the year, I'm going to teach you interval notation. Yes. The domain is all reals. All reals. Here's what it looks like. Domain is the elements of the domain. That means elements.
Are they always all reals?
For absolute values. Yes. And for any polynomial, any x squared, here's when the domain is not all reals, is when you have an x in the denominator. Then your domains are not going to be all reals. It's called a rational expression. Okay.